Good evening. Tonight we're going to start with lesson 16 in our fraction unit. I can use visual models to add and subtract two fractions with the same units. So if we going to go back to looking at these models, these tape diagrams to represent 3/4 and another area model to represent 2/4, and we can add them up and we can count. That is equal to 5/4. We're also going to bring in such as a number line to show that we're going to go from 3/4 to 4/4 to 5/4 to represent that on a number line. And we're also going to get into using units such as, like, we're used to saying 2 apples plus 4 apples gives us 6 apples. So those units such as apples we'd be talking about. But instead of using the word apples, we're going to be talking like 2 6 plus 4 6, is equal to 6 6, which is really a whole, right? So we got to get into these units, the 6 and the 6, to and the fourths. Like, these are units, and that's what we're going to be focusing on tonight, using area models and the adding and subtracting and using number lines. So let's get started. Okay, in our first example, it's asking 3 6 minus 2 6. So the unit is 6. So they're writing it out on word form, so we're going to answer this in word form. So let's look at the 3 and the 2. 3 minus 2 is 1, but be sure to write it in the word form 1 6. All right, the next one, it says 3/4 minus 2/4. Now we could say that this looks like this, 3/4. How come we just can't do that? Well, that is not what it's asking you for. It's asking you for the units, and so it's focusing on the word form, fourths. So we want to write our answer. If it's asking for that, stick with that. And so 3/4 take away 2/4 is 1/4. Next one, 5/10 minus 3/10. Well, let's keep it, because the unit is tenths, so let's keep it as into word form. And so 5 minus 3 is 2. And let's keep it in word form, tenths, 2 tenths. All right, 3/5 minus 2/5 equals, well, it's not asking you for that unit form to be written in word form. So now we can just keep it with the fifths, the unit form fifths as itself. So 3 minus 2 is 1, and the denominator stays the same because they're alike, so it becomes 1/5. Next one is 7/4 take away 5/4. Again, these are fractions that we would call improper, but they're fractions greater than 1. And in the numerator, the unit form is the fourths, and the numerator is 7 minus 5 is 2, and the denominator is 4, so it's 2/4. Now, guys, I've said this to you before. There's words called simplify, reduce, simplest form. So we're going to have to make these fractions that we're making, always check, once we have an answer, always check to see if it can be reduced. That means, again, that GCF that we spoke about, the greatest common factor. If we take 2/4, what is the greatest common factor that 2 and 4 share? Where the greatest common factor that they share is 2. So we're going to divide the top and the bottom by 2 to get a half, because 2/4 and a half are equivalent fractions. Solve. Use a number bond to decompose the difference. Record your final answer as a mixed number. All right. So we're going to take these, what we call improper fractions, but fractions that are greater than 1. We're going to subtract it. but we have to decompose it to help us get to that mixed number. They do not want our final answer to be a fraction that's greater than 1, that improper fraction. That would be incorrect. So that would be marked wrong because your answer has to be in a mixed number. And a mixed number, again, is a whole number attached to a fraction. That's what we're looking for, a mixed number. All right, so 12/6 minus 3/6. And we can solve this because our denominators are the same, and we're just going to subtract the numerators and keep the denominator the same. So 12/6 minus 3/6 is 9/6. All right, and now we're going to take this and make it decompose it using a number bond. So 9/6, we are going to take a whole from that, and that becomes 6/6. And then we're left with 3/6. So now what this is equal to, we have 6/6 that represents a whole, and the fraction left over is 3/6. So this is our mixed number. Now, I'm hoping that you are looking at that fraction and asking yourself, can I simplify it? Can I reduce it? Well, what can we do with that? We can we have to find the GCF, the greatest common factor. The greatest common factor of 3 and 6 is 3, excuse me. So we keep the whole as the same, that doesn't change. 3 goes into 3 once, 3 goes into 6 twice. So 1 and 3/6 is equal to 1 and 1/2. So the answer to 12/6 minus 3/6 is 1 1/2. Okay, the next one, we're going to subtract these improper fractions, the fractions greater than 1. And we have to have an answer. First, we're going to compose it to help get to our final answer, which should be in a mixed number, since these are fractions that are greater than 1. All right, so what is this equal to? Well, 9/5 take away 3/5 is 6/5. So now we are left with an improper fraction, or what we call a fraction greater than 0, and we need to decompose it. So how much makes a whole there? It would be 5/5, which would be a whole. And how much do we have left over? We have 1/5 left over. So now let's put that together. We've got 5/5, which represents a whole, and we are left with 1/5. So 9/5 minus 3/5 equals to a mixed number of 1 and 1/5. Now, always check your answers. If I look at 1/5, can I reduce that? Can they have anything that has a greatest common factor that can go into the top number and the bottom? And this does not have any common factor because the numerator already has a 1 in it. So it can't go down even more. So we are left with 1 and 1/5. Next one is 11/4 take away 6/4. And again, these are improper fractions, fractions that are greater than 1. And we are going to subtract our numerators since our denominator is the same. And 11/4 take away 6/4 is 5/4. And we are left with an improper fraction, a fraction greater than 1. So we need to decompose it. And let's get a whole from there, which would be 4/4. And we are left with 1/4. So now let's take these two and put them together. 4/4 is equal to a whole, and what's left is 1/4. So 1 and 1/4. Now, if you look at that fraction, we cannot reduce it because it's already to the lowest it can go. We can't go lower than 1. So this is already in simplest form. Okay, next one, we're going to be using addition, but our answer has got to be a mixed number, so we might have to be decomposing using number bonds. So 3/4 plus 3/4 is 6/4. All right, so we're definitely going to have to decompose to get to a mixed number because our answer is an improper fraction, which is a fraction greater than 1. So let's decompose it, and let's get a whole in there, which would be 4/4. And we are left with 2/4. Now let's put it back together. So we have 1 whole and a fraction of 2/4. And after we get our answer in a fraction problem, you should always stop and ask yourself, does this fraction in simplest form, does the numerator and the denominator have a greatest common factor that they have in common that I can divide the top and the bottom by to go smaller, to maybe to get to that 1 in the numerator if possible? And it does, because we already know this from experience. 2/4 is always equal to a half. So we can divide the top and the bottom by 2 to get 1, you got to keep that whole, 1½ So now it's in simplest form. Next one is 5/8 plus 7/8, which would equal 12/8. So now we have an improper fraction, a fraction that's greater than 1, and we're going to want to decompose it. So if we decompose it, we're going to break it down, and we got to make a whole, which would be 8/8. And then you're left with 4/8. Okay, so now let's put this back together. We'll have 8/8, which represents a whole, and you have a fraction of 4/8. All right, but as I told you before, when we're dealing with fractions, you have to stop and ask yourself, is 4/8 in simplest form? Does 4 and 8 have any common factors, the greatest common factor that 4 and 8 share? Yes, it does. And we've seen this fraction before, and it shares 2. So we can divide the top and the bottom by 2. Excuse me. All right, you know what? I'm gonna leave that, because actually it teaches you a good lesson here. 2 goes into 4 2 times. 2 goes into 8 4 times. Now you should say to yourself, well, wait a second, Miss Mulbieta. 4/8 and 2/4 are equivalent fractions, but 2/4 is not in simplest form. So I'm kind of glad I made that little bit of that mistake, because we need to put 2/4 and simplify it again by dividing the top and the bottom by 2 to get 1/2. What I should have done up here is take 1 and 4/8, divide, the greatest common factor would be 4, and we would get 1½ See how much all the extra work that we had to do to get to that? We had to divide by 2 up here, and then we had to do it again. That's why finding the GCF, the greatest common factor, helps us save a lot of extra time in just dividing the top and the bottom by the greatest common factor. Solve, but use a number line to model your answer. All right, so we can't just subtract it, we got to show it on a number line. So I'm going to create a number line, and I'm going to start with 0/9 and 1/9, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9, 9/9, which would be a whole, 10/9, and 11/9. All right, since we are going to be subtracting, we need to be showing it going down towards the 0, not up, because up would be showing addition. So we are over here. Here is 11/9. It's our starting point. And we are going to go down to subtract 5/9 from that. So here we go. 1/9, 2/9, 3/9, 4/9, 5/9. So we are stopping right here. So 11/9 minus 5/9 is equal to 6/9. Now you're going to say, why in the world do I have to create a number line to do this when I could have just subtracted 11 minus 5? Well, boys and girls, right now it seems probably very fair to you, But I promise the number lines are going to get are going to get more complicated as we go on later in 4th grade and then into 5th grade and 6th grade and all the way up. So let's just start using the number lines to model your answers. And I know it takes a lot of extra work, but do it because it's good practice for when the harder things come. All right, so now we're going to solve, and we're going to use a number line to model your answer for 13 twelfths plus 4 twelfths. So again, we're going to create that number line, and it's going to be into twelfths. All right, so I created a number line, and I started it with 13 twelfths. And the reason why I did that, why waste all the time by starting from 0 twelfths all the way to 13 twelfths if we're not going to be beginning at 0 twelfths or even close to that? So I'm starting my number line at 13 twelfths. And I'm going to be moving up this way because we are adding. And we're moving up by 4 twelfths to see where we land. So let's start here at 13 twelfths. And we are moving up 4 twelfths. So here's 1 twelfth, 2 twelfths, 3 twelfths, 4 twelfths. Ding, ding, ding. Here is our answer, 17 twelfths. Ah. No, try not, do, or do not. There is no try. I love that quote. Okay, let's start trying. Take Yoda's advice and try. Don't say I can't or I will not. You'll try. Solve. 5/3 take away 2/3 is, make sure we're answering in that unit form of thirds. Solve. Now, please make sure that our answer needs to be in simplest form. Please make sure you're finding that greatest common factor. 6/6 minus 4/6 equals, be sure in simplest form or it's going to get marked wrong. Solve. And your answer needs to be in simplest form, 7 twelfths minus 3 twelfths. Now, I forgot to tell you in the previous problems, but I want to see all your work tomorrow. Solve. Use a number bond to decompose the sum. Answer needs to be a mixed number. If it's not, it'll be marked wrong. So, I want to see your number bonds and your work tomorrow. Solve. Use a number bond to decompose the sum. Your answer needs to be a mixed number. I want to see your work tomorrow. Solve. Use a number line to model your answer. I want to see your number lines tomorrow. Your options according to Yoda. The white do, the black is do not. There is no yellow or orange in this circle. This is wonderful advice to live by. Just always try. Good job, 4th grade.